Assalamualaikum and hi everyone. Galvanic cell part 4. You are going to learn about draw and explain the standard hydrogen electrode She and construct standard reduction or electrode potential series by using She.
We can use the She to measure the potential of other kinds of electrodes. For example, let us consider one electrochemical cell with a copper electrode and a She. In this case, the copper electrode is the cathode and the She is the anode. We deduce the effect from the increasing in mass of copper electrodes from the operation of the cell, which is consistent with the reduction reaction. At the anode, the hydrogen gas is bubbled into a hydrochloric acid solution. The platinum electrodes provides the surface on which the oxidation takes place. Hence, the hydrogen gas is oxidized into H+ ions and release 2 electrons. The H+ ions enter the HCl solution. 2 electrons moves from the platinum electrode to copper electrode through the external wire. The voltmeter displays the value of standard cell potential, which is positive 0.34 volts. At the cathode, the copper 2+ ions from the copper sulfate solution reduce to copper solid and deposited on the copper electrode. As the result, the mass of copper electrode increases. As the reaction proceeds, the anode half cell is rich with positive ions, whereas the cathode half cell is excess in negative ions. To maintain the neutrality, the chloride ions from the salt bridge migrate to the anode, while sodium ions from the salt bridge move to the cathode. We can write the half cell reaction as follows. We can calculate the standard reduction potential of copper by using the formula of E naught cell is equals to E naught oxidation plus E naught reduction. From the calculation, the standard reduction potential of copper is positive 0.34 volt. Another useful equation for determining E naught cell is given as E naught cell is equals to E naught cathode minus E naught anode, where both E naught cathode and E naught anode denote the standard reduction potential respectively. The standard electrode potential of zinc can be obtained in a similar fashion by using a cell with zinc electrode and a She. In this case, the zinc electrode is the anode because its mass decreases in the operation of the cell as it's consistent with the oxidation reaction. At the anode, zinc electrode is oxidized to zinc 2+ ions and release 2 electrons. The electrons produced at the zinc electrode move through the external wire to the platinum electrode of She. The voltmeter displays the value of standard cell potential, which is positive 0.76 volt. At the cathode, H+ ions from the HCl solution is reduced to hydrogen gas by gaining 2 electrons. As the result, we can see bubbles of gas released at the cathode, which is the hydrogen gas. As the reaction proceeds, the anode half cell is rich with positive ions, whereas the cathode half cell is excess in negative ions. To maintain the neutrality, the chloride ions from the salt bridge migrate to the anode, while sodium ions from the salt bridge move to the cathode. We can write the half cell reaction as follows. The standard reduction potential of zinc can be calculated by using the formula of E naught cell is equals to E naught oxidation plus E naught reduction. From the calculation, the standard oxidation potential of zinc is positive 0.76 volts. We can evaluate the standard reduction potential of zinc by reversing the oxidation reaction. Remember that whenever a half cell is reversed, the E0 sign also changes.
Let us consider for the following reaction. So the E0 value is positive 1.36 volt. If the reaction is reversed, the sign of E0 changes. For example, like this. So the sign is changed from positive to negative. However, the magnitude is remain the same, 1.36 volt. However, when changing the stoichiometric coefficients of a half cell reaction does not change the value of E0. For example, the first equation here, the whole equation times by half and become like this. The value of E0 is still remain the same, positive 1.36 volts. So in conclusion, when the reaction is reversed, the sign also change. Okay. However, changing the stoichiometric coefficient does not change the value of E0.